All right, welcome everybody. So today we're going to be talking about access control lists. Chad Lavoie, who is our Director of Support, is going to be guiding us through the power of using our ACLs and HAProxy. And with that, I'm going to hand it over to Chad.
Greetings. So I'm going to be talking a little bit about ACLs. The first question is, of course, what is an ACL? I'll start this by going over a couple of examples. Don't worry about the specific syntax you see here. We'll be going over the individual parts of the syntax now. I just want to give a few examples of what ACLs are commonly used for by showing some practical examples. This first example, it will use a backend BE example if the host header contains example.com, the case-insensitive domain match. We'll go over that later, but that's relatively commonly found. This is a more advanced version of the above, which is rarely seen, but I include it because it's using log format lines, which we'll get into and are closely related to ACLs, to dynamically calculate a backend name based upon a map lookup of the host header. This is probably the most common ACL seen in HAProxy configurations. It simply redirects from HTTP to HTTPS with the same URL that was requested if the connection was not made over SSL. This is what is known as a named ACL, which, if put in a config, will do nothing on its own. However, will allow other ACLs, such as this, to trigger based upon the source IP. And this line will deny a request if the source is not, if the client making the request is not in the given subnet, and if the path begins with /admin. We can get even more complicated than that, and we can redirect the location to login if the client did not authenticate with a client certificate to SSL, or if the client has not authenticated with Lua, which would have to be defined elsewhere. So this is obviously significantly more complicated, but gives you some idea of how complicated things can get. This is a capture, which is not as closely related to ACLs, but I use it frequently especially if I'm dealing with large amounts of traffic and one of my fetches isn't doing exactly what I expect. You can use an HTTP capture in order to include a given fetch into the logs. This is very useful for, in this example, capturing a request rate of clients so you can determine thresholds. You can also capture headers, you can capture body parts, all the sorts of different things can be done via capture. So it's something important to keep in mind, especially as figuring out why an ACL is doing what it's doing. So where are ACLs found? You'll find ACLs in front ends, back ends, or listen sections of HAProxy configs. In most cases, you will find the majority of ACLs inside front ends, which is where traffic initially enters HAProxy. You can also, generally, I will put all my ACLs that are doing things such as denying requests or redirecting requests in a front end, and I will only put ACLs in the back ends which are doing things that specific to the backend servers. For example, if I need to override the host header for the backends to be happy with the requests, regardless of the front end the traffic came in from, or if I need to use ACLs to modify persistence, that kind of thing, but 99% of the time I just put it in front ends. Listen sections are mostly depreciated. You will sometimes see ACLs in there to restrict access to stats pages based upon IP addresses, but in general, listen sections are not used for ACLs, because if you start redirecting to different backends from a listen section, you will very quickly go insane trying to read your configuration. Normally ACLs were executed in order from top to bottom of the config. So as we go through the actions, that's pretty much how you define what order they're processed in. If a something goes through and sends it to a different backend, that will stop processing and that type of thing. The exception to that are that they are processed in TCP connect to TCP content, HTTP request, HTTP response action phases, which we'll talk more about later. If you have your ACLs in an order where they will not execute in the order they're in the config, you will get a warning from HAProxy when you do a config check or start HAProxy. So if you're debugging that type of thing, checking for those warnings, and I would recommend reordering even if the warning is harmless, simply so that unexpected warnings can be seen. So what does an ACL look like? Here we'll get into the individual parts of an ACL and what makes them tick. The first part of an ACL is the action, which in this is all these examples is use backend be toaster, which would send the request to a backend named be toaster. And then you have the ACL. Either you can have an inline ACL where you have the ACL on the same line as the action itself, or you can use a named ACL, which would require having an ACL definition, and then you can use the named ACLs. Each of these you can use an if, you can use an if not, or you can use an unless, which is basically the same as an if not, but it's easier to read depending on what your conditions are looking like. So the fetch is the first part of an ACL line. The ACL line will always start with a fetch of some sort, and if you start the ACL line with a converter or something, HAProxy will complain at startup and refuse to parse the configuration. And so if you see an error like HAProxy telling you that it was expecting a fetch and it got a converter, or it got a converter was expecting a fetch, that is the first thing you should probably look at. Especially when you get into complicated ACLs, that becomes easier to make mistakes like that, and you'll probably see them eventually. A fetch will retrieve a data sample from the HAProxy state. So it can get a host header, it can retrieve the SL session ID, it can receive the source IP address. There are a whole variety of fetches we will go over, and from the fetch you will then pass it optionally to converters, and then via match flags, which we'll also get into, it will compare it against a value. Some fetches will take arguments such as req.hdr host, which you saw in some of their examples previously. This will return the first host header in the request buffer. Some will just retrieve the value without any prompting, such as SSL FC session ID, which will just return the SSL session ID. The most popular fetches are URL param, which takes an argument of a get argument name and will return the value of the get argument that the client presented. Source, which just returns the source IP address. The req.hdr, which returns a request header. Cook, where you pass a cookie name and it returns the cookie value. Rand, which returns a random number useful for sending partial amounts of traffic to another server, perhaps combined with a cookie for persistence. NBServe, where you pass it a backend name and it returns the number of active servers in the backend which are considered up, which is very useful if you're sending a small amount of traffic to a testing cluster via RAND. You can use NBServe in order to check if their backends are actually up, so that if the entire staging cluster is offline for maintenance, it will not use it at all. Payload is actually not terribly popular because of its nature. It returns part of the request body, which is very useful in TCP connections, where you're dealing with other protocols and you want to do binary matches in order to detect the difference between VPN traffic and SSL traffic if there isn't a fetch to detect your protocol, for example. They are all listed in the docs under the fetches section, and Control F is your friend to find. You can search for keywords to find the fetch you're particularly interested in. Or if you're an enterprise customer, you can, of course, contact support, and we'll be happy to point you in the right direction. Converters are chained after a fetch with commas. Converters are completely optional, so you can just have a fetch with no converters at all, or you can have multiple converters. In this first example, we have the host header is being retrieved via a fetch, which is then being converted to lowercase via the lower converter, and then we're taking the first 5 bytes of it, which would then continue on to be matched via flags and values. As with fetches, you will see some of them take arguments, such as the bytes converter, which takes the start and end bytes. Some of them don't take any values, like lowercase, which just reduces it to lowercase, or its friend uppercase. Some of the most popular is obviously lower to change the case, or its friend upper to make it all uppercase. The bytes fetch allows you to extract particular bytes from a request. Hex will convert the input sample into hexadecimal, very useful for things like SSL session ID, which returns a binary value. Base64 is very similar to hex, except that base64 encodes it. That's very useful if you want to log the request body in a log file, where you need to convert it into something that will not corrupt your log with binary data. Map is a converter which takes an input sample to look up in a map and returns the value found in the map. We'll go over maps more in a later section here. Field allows you to take something like you pass it a separator, so a comma, for example, and an index, and it will return the field in a sample. So if you have a get argument with a comma separated values and you want the third value, you could do field open parentheses comma 3, and then you get the third value from it. Mod is one of a few math options you have, which is a modulus. You also have division, multiplication, addition. All of the fun stuff is done by converters, where some of the others you'll pass the say addition and argument for what you want to add. Reg sub is a special one where it will perform a regular expression substitution on the input, which is frequently used for conditions like rewriting a URL with a regular expression if you can't do it statically. Log format rules. This we've talked about a little bit, and it's very similar to HAProxy, and it's used for a lot more, very similar to ACLs rather, and it's used for a lot more than simply log formats. In this case, you can see we're using an HTTP set path to include the host header and then append the actual path. So if you were making a request to example.com/foo, that would change the URL to /example.com/ and then whatever foo for the to the actual backend without notifying the client of anything. This is also, you can put any form of fetches in here. You can also put converters. And you can put that onto set headers to set a request header, response header. You can set query strings, set paths, set vars, obviously log format, and there's a few other things. If you're doing logging, you may sometimes run into cases where you don't have the information available. We'll get into variables to get around that in a later section. If that's the case, you'll get a warning by HAProxy on startup. So the middle section between your fetches and converters in an ACL are your flags. You will have 0 or more flags. If you don't have any flags, every input sample, for example, string is a direct match. IP address will match the IP or IP ranges. You can also specify a given converter via the -m. You can put as many flags as you want in there. The available flags are -I, which makes a match case insensitive. You'll see that very frequently. You'll do req.hdr host space and then a -I to make it case insensitive, and then space example.com to match example.com, for example. -M sets the match mode. We'll go over the available match modes in the next slide. -F allows you to check for the input sample in a ACL file. With the -F, you will not put any value to check against at all. You just have a file with one sample per line, and if the match is if the sample changed by the match mode is in the ACL file, it will be true, and it is useful for things like having a bunch of static URL paths or having a bunch of domain names that you want to send to a given backend, that type of thing. Less common flags are available are -N to forbid DNS lookups, a capital M to lose a map file like an ACL. Usually I will use -M found, which we'll get into later instead of -M, or -U, which is almost never seen, but allows you to specify a manual ID for use if you're using the runtime API to update ACLs during the runtime. You will probably never use any of the less common ones unless you have a very particular case, so I wouldn't worry about them. So when you're using -M, you can pass it a whole bunch of different options for different things. You can do -M-BEG, which matches the beginning of the string. So if I have path -M-BEG / admin, it will then be matched true if the path starts with admin regardless of what's after it. You can use -M-end to match the end of the path, which is frequently used for file extensions. So I could do path -M-end space .png space .svg, and then if the extension is PNG or SVG, the ACL will match. So you can send the requests to a static request. You can also use -M sub, which is similar to begin and end. It just matches if the sample is, if the value anyway is anywhere inside of the sample. M-DOM is a domain match, which basically is a substring match, except it expects it to be terminated with separated with periods. So if you have if I'm matching against example.com and this input sample is www.example.com, it will match. But if it's example2.com, it won't. But it will also match against things like foo.example.com.bar.com. So if you're dealing with security, where the attacker may be modifying your host header and you do not want to allow that, that is something to keep in mind. And some of the other fetches like end might be more interesting to detect the end of the host header. You can combine the any of the match modes with a -F, or I'm getting ahead of myself. We can use -M-reg to specify a regular expression to match against the path. This is will be CPU hungry, but is a very useful way to detect which paths you're dealing with, especially if it's complicated enough where you can't do it via begin and sub, which I would almost always recommend doing if you can. You can combine any of the match modes with -F, which will load the patterns from a file. Otherwise, you just specify the values directly on the ACL line. This is, if I haven't made it clear thus far, this is all the same between named ACLs and anonymous ACLs. The only difference is the anonymous ACLs have the ACL part in a block. The named ACLs just have ACL, then the ACL name, and the rest of the ACL. The syntax and capabilities of the two are exactly identical. You can -M found is the other last match mode, which is a special one, which allows you to determine if a given fetch is available or a given converter is available. In this particular case, that would this example will deny any request if the host header is not present in the request. You can also do it with maps, so you could do req.hdr host, comma map with a map file -m found, which would be false which would return true if the host header is found in the map, and you can use unless to detect if it's not in the map, that type of thing. If you do, that's a way around. If you normally, the way it used to be done in the good old days was to just have the fetch in place and it would return true, but now you use -m found to determine if it's present, regardless of whether it matches anything or not. Some of the match modes will have, some of the fetches rather have built-in match modes. These are simply shorthands. For example, if I want to detect the beginning of a path, instead of doing path-m begin /admin, I could do path_beg /admin, and that will do exactly the same thing. Not all fetches have these variants, but the big ones that usually do will offer beginning dir for a directory match, which is similar to domain match, except separated by slashes. You have domain match, end length, which matches against the length of the input string, regular expression, and sub. The big ones like path have those, and map also has them. But a lot of the other fetches will not have any of them, but you can still do matching modes using -m as needed. You can match numbers with ACLs using another type of command. So if you want to detect if the rate is greater than 50, you just put the fetch followed by any converters and then space GT and then space and another 50 to detect if it's greater than 50. You can use EQ, EQ for equality, GE for greater than or equal to, GT for greater than, LE for less than or equal to, or LT for strictly less than. You can also specify a number range with colons. You generally, you don't see colons terribly often for ranges in ACLs, but you will see them frequently when you're writing ACLs to detect an SSL version, because you can do TLS 1.0 if the req.ssl verb fetch is between 3 and 3.1. In that particular case, it'll also detect SSL3, which has the value of 3, and it will detect TLS1, which has the value of 3.1. Usually you will, if you just want to block older SSL versions, you will use SSL min version in the global or default sections, and you will not use that, but that's very useful if you want to redirect people using an old cipher to a warning page, or track it in a stick table, or that type of fun stuff via ACLs. So then you get to your values. Basically, so after you've specified your fetches with any optional converters, you've specified your match mode, then you specify the values that you want to match against. You can specify one or more values. If you specify multiple values like this, where we have /images and /icons, if either of those are if the path begins with either of those, then this will match. You can do the same thing with source IP addresses, where you can specify either straight IPs or IP ranges, and you can specify as many as you want. If that starts to get too many, you just go to the point of using a -f and specifying a file, and you can list out all your admin IPs there. You can also do binary matches, for example, to detect that they want to go to a multiplayer server if the first 4 bytes of the request matches this hex string. You will generally rarely see that except in advanced use cases, but it is important to be aware of when you get put in a situation where you need to use that. The value at some point does have to be a static value of some sort. It either has to be in a file or it has to be on the command line, but you cannot compare two different fetches or converters, though using some of the mathematical operators, there are ways around that. That typically gets very complicated, and generally you don't have to worry about it. But if you do run into that problem and you need to compare one convert fetch to another, you're either looking at using math to do it, or you can write a workaround via Lua. So actions. These are what you will use your ACLs for now that we've come up with a full ACL. So we have some examples here of ACLs. This is so your action will start with either HTTP request, TCP request, which we will get into all of the actions available later, but HTTP request is probably the most common action. You can specify a bunch of things after HTTP request, which is all in the request phase, such as redirect to redirect requests with a scheme. You can redirect the full location. You can set a path, so you can change that just changes the path in flight between the client and the backend without performing a redirect, so the client will never know that the backend got a different path request, which is useful for things like adding /legacy or adding a domain name to a path instead of using a host header, that type of fun stuff. You can set a request header, which will add a header that the backend will see, such as X page viewed with a general purpose counter, which is a more complex stick table topic included as a value, but this is log format, so you can use any fetches or converters to add any type of headers you want for map lookups or all sorts of fun stuff there. You can also use HAProxy cache use, which uses the new caching to respond with an item if it is cached. That needs to be combined with the cache store in order to actually do anything, but that is the basic ACL you'll use to get started with caching. You can the second most common outside, or probably maybe the most common, depending on how if you count the SSL redirects for ACLs, is use _backend, which is if you have default _backend in a backend, which is your typical one, any requests that fall out of the front end without having a specific backend set will go to the default backend. Use backend allows you to specify a backend, which at the line it's executed, so it will send it to the backend. So if you have a bunch of ACLs, then a use backend, and then more ACLs, only the ACLs and actions above the use backend would be executed, because once it hits use backend, the request will be sent to the other backend. So ordering in this case is important. In these examples, we have using a backend based upon the host header. We can build one dynamically based upon just the host header instead of a map lookup like we had before, or we can do a full lookup map ends to check against if any of the domains end with the strings in a map file. The map file in the second column would have the backend name, which would be prepended with BE _. So in order of the phase, you can have a TCP request connection, which will be very early on in the request will use it, and anything that's blocked at the TCP request connection level will not generate a log entry. Generally, the only reason you will ever use TCP request connection is if you're dealing with request rates that are extremely high for denial of service, and you need to block them immediately, if not sooner, without wasting any of HAProxy's processing time that you can possibly avoid. TCP request content is where HAProxy will actually have some of the content of the request available. This can be used to detect what protocol is being used in TCP mode. Generally, if you're using mode HTTP, you will not use TCP request content. You will generally use your HTTP request fetches, but a TCP request, if you're using mode TCP, is as far as it goes, because in mode TCP, it will not process the HTTP request or response. HTTP request is where you put your set headers, set paths, all that fun stuff for the request coming from the client to the backend. And HTTP response allows you to inject headers or block a response based upon once the response is coming back from the backend before HAProxy sends it to the client. I skipped ahead accidentally, but that is basically your major phases. So variables, we're running a little bit short on time, so I'm going to speed up on some of these advanced topics a bit. We can do a more advanced webinar on the in-depth topics later if you want. But variables are used when you want to do fancy things like log a value that, because HAProxy is very aggressive about freeing memory as soon as it possibly can. So as soon as it makes the request to the backend, it will immediately forget what the path it requested was to free up the memory for future requests because it doesn't need it. But if you need it to store that kind of thing, you can use variables. This is a very complex example of setting maps to make a pseudo API to allow a backend to set the what backend a client will use based on its session ID cookie. This is the kind of very complex thing you can get into with ACLs. And if you need to do that kind of thing and need help writing it, I would highly recommend contacting support, because I've played with them, and if you have a complex request like that, I can probably write it quickly, but this is the kind of type of very complicated thing you can do in HAProxy as a whole. You will generally not need to run into variables unless you're doing very complex things like checking the cookies or path on a response backend in a response phase that were only available in the request. Generally, you can write your ACLs as if the variables don't exist, and if HAProxy prints a warning or error in the when parsing the configuration that that whatever fetch you're using is not reliably available in this phase, you will know that you have to use a variable in order to you could use a variable at the phase that the information is available in to keep it available. But for complex things like this, you'll have to use variables immediately. There are all sorts of details to variables. Due to time, I will not cover all of them, but there's a variable section in the doc that explains it relatively well. Map in ACL files. I'm going to give you a whirlwind introduction to those. We actually have a blog post dedicated to map in ACL files. However, we have, a map file is used to look up a value and return another value, and an ACL file just has a single column with samples to match against. So both are stored on the disk and loaded at startup. ACLs have just one single column of the value to match against, the same as exactly as you've seen with the values that we've matched against in ACLs thus far. Same syntax, just one value per line. Maps have two columns, where the first column is a value, and then the second is what is the value that you want the map to return. Very useful for things like classifying. If you're doing something like admin net, this might be used to add a header to a request to the backend, so it can easily determine that a request came from a given cluster of IPs, that type of thing. You can update the map and ACL files via runtime API commands, or you can use the HAProxy Enterprise LB update module to give it a URL to download the ACL or map file from automatically. ACL files are just one sample per line. You can put IP addresses, you can put binaries, you can put strings, you can put regexes. If you stick to full strings or IP addresses, HAProxy will use a binary tree during lookup. So you can have millions of entries of either IPs in maps or just plain ACLs, and HAProxy can do the lookup without any without any speed at all. If you use beginning, end, or regex matches, HAProxy will have to process each one of them. So regex obviously being the most expensive, but it will eventually introduce a slowdown. Maps, ACL files are just done with -F and your file name that you want your ACL file to use. When updating via the command line, you'll use the file name. Additionally, we have a blog post on the Runtime API which will cover that. You can do all sorts of fun things using HTTP add ACL to add and remove ACLs via the requests. So you can use that to make a pseudo API for HAProxy, which is useful if you want to allow a backend. You could, in this particular case, this would allow a server in a given subnet to block IP addresses. Dynamic to add and remove IP addresses to block. If you're using NB thread, you can do this without any concern. If you're using NB proc, which has multiple processes, however, each process will have its own view of the ACL, so you're better off using something like LB update to distribute the ACL file to all of your processes, or using a shell script that loops through all your processes. Map files are sort of similar to ACLs, except instead of using the -F argument to match against the ACL file, you are using a map converter to pass the input that you want to look up in the map, and then the map converter will return whatever the result of the lookup is. You can use all of the common match modes to match the beginning, directory matches, domain matches, end matches, length from the maps, which will change how it looks up the sample in the map to come up with the answer. If more than one sample can match, especially if you're using begin or end or that type of thing, the first matching item in the map will be used. And this is used for all sorts of fun things like mapping host names to backend names or storing rate limits for a given key. You'll see examples of this in some of our blog posts, or if you if you're running into any condition where you have a lot of things you need to look up and convert to one string to another, that's where it's used. This is a quick example of how you would use the LB update module to update a file, the block ACL file that we used before, from a given URL. So now I'm going to open it up with questions with about 5 minutes left, and I'm happy to answer any questions about ACLs or anything I've overlooked in this process. If anyone didn't hear, you can use the chat option to ask questions. I don't see any immediately here, but if you ask them, I'll be happy to answer them as they come in. Or if Nick has any that are stored up in his head he wants to he has seen. Hey Nick, can you process and can you see any of those questions? I see lots of questions, but I can't make any sense of them in the interface immediately. Do you have it widened out or something so you can read them?
Unfortunately, I can't see the questions. I can see the chat window. I may need to be created as an organizer real quick.
The questions are above them. Unfortunately, I'm not particularly familiar with this interface. I'll get it working eventually, but I would recommend asking any questions in chat initially, and at least until I figure out what on earth I'm looking at.
Hi, Chad. There's a question. Can we create ACLs for source IP address?
Yes, you can if you do something like let's see if I can go back to my first slide here. Let me just exit this so I can go back to the slide in question. Where was the slide with the source IP match? Okay, so if you did something like this, this is a named ACL for this. This would match is admin range will be true if the source IP is in the 10.48.0/24 subnet. And then you can do HTTPS deny if not is admin range, or you could do HTTPS deny if is admin range, which would be more of a blacklist. And you can also do this with, instead of putting this here, you could do a -F for a file name, and then you could have a list of IPs or ranges that you wish to block or allow for a given use.
Another question is, can ACLs be used to add HTTP basic authentication to a backend?
You can. It's a little bit more complicated depending on the type of authentication you're using, but there is an HTTP request auth action, which you can if you just specify HTTP request auth to a request, HAProxy will respond with a 401 requesting the backend send a username and password. So you'll do HTTP request auth if I think it's HTTP group. I'm trying to recall there's a fetch which allows you to use, if you search for user lists in the docs, you'll see the methods for adding a user list to HAProxy. In addition to that, you could also have HAProxy using the req.hdr header, look up the authentication header and use base64 decode to decode it, and then split using the field split. You could split the username and password on the colon and look it up in a map or something if you don't want to use the HTTP, if you don't want to use the user list built into HAProxy. So there's lots of options for that.
Another question is, what is the best practice to manage HAProxy CFG, all ACLs at the top followed by backend, or ACL along with its backend?
My general, I actually forgot to mention that, and I was meaning to specifically go over that. Usually what I recommend is you use a named ACL. For example, this source IP example or the host example if I'm only going to reference it once. But if I'm going to do something like have a big long list of use BE example and BE foo and BE far foo based on the host header, I will use inline ACLs because I will very quickly start to go insane if I have to look at a if I have to look at an HTTP request, use backend line, and then look back up to see what the ACL actually was, and then look back down to it. So I will use inlines if I'm only going to reference it once. For example, just sending it to a backend based on the host header.
Another question would be, Steve says this might be off topic, but could you provide an example of setting up sticky sessions in HAProxy config or a link to a blog post? I think we can send that resource to all the viewers, and we will send the recording of the webinar. So I think that
sure. Yeah, we can. Stick sessions are a little bit. There's so many different ways to do it. It's hard to for me to describe all of them. You can combine them with ACLs. For example, you can do stick on cook session ID if if session ID -m found or something. You can get, that's generally a much more advanced use case for sticky sessions, but you certainly do combine ACLs and stick sessions sometimes when you start getting into very complicated persistence setups. But usually sticky sessions are mostly not used with ACLs for 99% of cases, but you will see the two used together sometimes, and we can send you resources on how to configure sticky sessions though.